Hello everybody and welcome back to question number 24 on the 2001 grade 8 Gauss paper. So question 24 says, a triangle can be formed having side lengths 4, 5, and 8. It is impossible, however, to construct a triangle with side lengths 4, 5, and 9. Ron has 8 sticks, each having integer length. He observes that he cannot form a triangle using any 3 of these sticks as side lengths. The shortest possible length of the longest of the 8 sticks is... Okay. So this is actually a bit of a classic question. When I do these, I try and go into them, not having looked at the question ahead of time, not having prepared. But this is one that I've always remembered for years, because it turns out what we're going to see is the shortest sticks follow the Fibonacci sequence. Now, even though I know that, I'm going to approach it as though that isn't an obvious answer. I'm going to talk a little bit about how we construct the triangles, but I think it's really neat that the Fibonacci sequence shows up. This is an excellent example of how to generate the Fibonacci sequence, which is a very famous mathematical sequence of numbers. It goes 1, 1, 2, 3, 5, 8, and so just looking at our potential answers, 20, 21, 22, 23, 24, 21 is the only one that's a Fibonacci number, so I already know the answer is going to be B21. But suppose we didn't. Suppose we didn't. Well, let's talk a little bit about triangles. When can we make triangles and when can't we? They're telling us that 4, 5, and 8 can make a triangle, whereas 4, 5, and 9 can't. So let's talk a little bit about that. So if I have a side length of 8, I can just about get 4 and 5 here. 4 and 5 and 8. But if I try and do one with 9, I find that because the 4 has sort of got to stick here and it hinges there, and 5's got to go here, and they sort of can move around and eventually they meet, and that's what forms a triangle. But 4 and 5 will finally meet exactly along the triangle itself. Exactly along the length 9, that rod, and so we get to what's called a degenerate triangle. It's basically just a line. Okay. Are they rods or are they sticks? I can't remember. He has 8 sticks, so let's talk about sticks. So for sticks of length A, B, and C, and suppose we know that A is less than or equal to B is less than or equal to C. So we're just saying if there is a longest, it's going to be C. If there is a shortest, it's going to be A. That's all we're saying. Turns out you can only form a triangle if A plus B is greater than C. Okay, that's exactly when it'll happen. So here 8 is the longest stick. 4 plus 5 is greater than 8, so we get a triangle. Whereas here 9 is the longest stick, so 9 is equal to C. And A and B are 4 and 5. A plus B is 4 plus 5 is 9. That is not greater than 9. It's equal to 9, so it doesn't work. So we have this nice little property. For any of Ron's sticks, of length A, B, C, with A less than or equal to B less than or equal to C. If we take any 3 of Ron's sticks, we can order them. And we know we can't form a triangle with them. So we can't have A plus B is greater than C, so we must have A plus B is less than or equal to C. Okay? Now we're told in the question that Ron has 8 sticks. Now I don't really know where to begin trying to figure it out for 8 sticks. And when we're confronted with that on a contest question, a good idea is to take the sort of offending term or the big scary number like 8 in this instance and drop it down to something a little more reasonable. How about 3 sticks? Ron has 3 sticks, and no 3 of which can form a triangle. What's the shortest possible length of the long side? So let's solve that smaller case. See if we can learn something, maybe build onto it, maybe add in a 4th stick afterwards, and see if we can work our way up to 8 sticks. Okay? That's always a good idea. Reduce the problem, make the numbers a little nicer, but still retain the essence of the problem. We're retaining the essence by asking, what if Ron only had 3 sticks? Okay? Well, we know that he's got to have a positive integer. Each one has a positive integer length. Okay? So, for 3 sticks, you know what? Let's make it a little easier. What if Ron only had 1 stick? Well, if he had 1 stick, it's got to have positive integer length. So the shortest that 1 stick can be is 1. Okay, what if Ron had 2 sticks? Well, 2 sticks won't form a triangle, so we don't even need to worry about that. What's the shortest the longest one could be? Well, there's no reason they can't both be 2. Or sorry, they can both be 1, so both the 2 sticks can both be length 1. So if he has 1 stick, the length 1 will do. If he has 2 sticks, they can both be length 1, and so then the longest stick, which is either one of them, will have a length 1. That's definitely the shortest that could possibly be. So now we've worked our way up to what if 3. Okay. Well, we know he could have 2 really short sticks of length 1, and that's the shortest that those can be. Because it'd be really nice if 1 was the answer again. Unfortunately, no, because 1 plus 1 is greater than 1. 2 is greater than 1, so we'd be able to form a triangle. We'd have an equilateral triangle with side lengths 1 on each side. Okay. So I like the 2 sticks from before. A length 1, 1, and a length 1, 1. So we're going to let C be the length of the 3rd stick. Well, we know since we can't form a triangle, we must have 1 plus 1 is less than or equal to C. And I want the longest stick, which in this case will have to be C. C is at least 2. I want that to be as short as possible. So choosing something like 3 wouldn't work because 1 plus 1 would be less than 3. And we could always bump C down to 2. So really our new stick, C, should be 1 plus 1, which is 2. Okay? So the shortest C can be is 2, and that is going to be the longest stick. So far, we know we can have 3 of Ron's sticks can be 1, 1, and 2. Okay, that's what happens if he has 3. What about if he has 4? Right? Let's suppose he has a stick. He has the sticks 1, 1, 2, and D. Why am I picking 1, 1, and 2 as the other sticks? Because we already showed when we considered 3 sticks that 1, 1, and 2 should be the smallest grouping there. So if I want D to be the smallest, because I'm going to want D to be less than this, or greater than or equal to this, or that one, or the other pairing, which is... Here, let me explain this a little better. So, let's say that he had sticks of length A, less than B, less than or equal to C, less than or equal to D. We can always order his sticks. D is the longest. Okay? In order for... we know that ABC is going to not be a triangle. Okay? We know that ABC cannot be a triangle. And if we want to make D as small as possible, we probably want C, B, and A to be as small as possible. That gives D the most room to be really tiny. So that's the smallest example of 3 sticks that can't form a triangle. And since it's the smallest, that gives the smallest C value. And that tells us D is at least 2. Okay? If we could have picked a bigger one, like 113 also doesn't give us a triangle, but then that would have forced D to be at least 3. And we want to give D as much space, as much opportunity, as much possibility as we can. So that's why we choose 112 here. Okay? But we know that 1, 1, and D can't be a triangle. We know that 1, 2, and D can't be a triangle. So I was using the first one. And using our second one, B, we know that... let's write it out. So we also know that A, B, D, A, C, D, and B, C, D can't be triangles. And so that means that A plus B is less than or equal to D, A plus C is less than or equal to D, and B plus C is less than or equal to D. Well, that's 1 plus 1, so D is at least 2. Here we get D is at least 3, and here we get D is at least 3. So we're going to let D equal 3 again. Now suppose we wanted to go to 5 sticks. Okay, so what about 5 sticks? Well, we'd have A less than or equal to B, less than or equal to C, less than or equal to D, less than or equal to E, and E is the longest stick. Now we know A, B, C, and D can't form any triangles, so it makes sense that we would say that A is 1, B is 1, C is 2, and D is 3. We also know that A, B, and E can't be a triangle. A, C, and E can't be a triangle. AD and E can't be a triangle. BC and E can't be a triangle. BD and E, and finally C and D can't. CD and E can't be a triangle. So what we could do is we could say, well, E's got to be bigger than or equal to AB, or A plus B. It's got to be bigger than or equal to A plus C, A plus D. But really, the only one we need is this last one. We just need to satisfy C plus D is greater than or equal is less than or equal to E. Why is that the only one we need to satisfy? Because for every pair, AB, AC, AD, BC, BD, and CD, all those values are going to be less than C and the pair C and D. So CD is that's where we get the biggest sum. So if we take any pair of shorter sticks and the longest stick, we know we can't form a triangle there. So we need the biggest sum here. So it's C plus D, the last two that we figured out, 2 and 3. So we see that 2 plus 3 is less than or equal to E, so 5 is less than or equal to E. We want E to be the shortest, so we let E be 5. Now let's just talk about what would happen if we had a sixth stick. Well, from what we've learned, we know that 3, 5, and F can't form a triangle. So 3 plus 5 must be less than or equal to F. To make F the smallest, we don't use the less than, we use the equality. So we make F equal to 8. Okay? So that's our sixth one. How about a seventh one? Well, you might notice a pattern by now. We just take the next two biggest and we add them together. That's what we did over here. 2 plus 3, those were the next two biggest sticks. And that gave us the next stick. Here we have 3 plus 5. That gave us the 8. So we would need 13. And that would be the 7th stick. And finally, the 21st stick would be 8 plus... Or sorry, not the 21st stick. The 8th stick would be 8 plus 13, which is 21. And we said that that was B. Okay? Now, if you didn't know what was going on in this problem, that's okay. If you had guessed, you would have guessed the smallest one, most likely. Most people, I find that most people, when they push to guess on a greatest value or a lowest value, they usually guess 20. Or sorry, they usually guess the lowest or the highest value, depending on what the question's asking for. So this really illustrates that you shouldn't be guessing, especially on these harder questions. If you don't know it, leave it blank. You get 2 marks for leaving something blank. So if you guessed 20, you would have been wrong. It was actually 21 was the correct answer. Right? It says so right at the start of the contest. No penalty for an incorrect answer. Each unanswered question is worth 2 marks. Okay? So if you don't know, if you really don't know and you're writing this contest, don't guess, unless you can narrow it down to 1 out of 2 choices using some math. If you don't know, don't guess. Leave it blank. It really does bump up your score, and it can be quite good. It can be the difference between a school medal and, I don't know if they still give out certificates or not, but it could get you a school medal. It could get you noticed by someone. Anyways, that's question number 24. We have one more question to go. That's question 25, and we'll take a look at that in the next video. So thank you guys so much for watching, and as always, I'll see you next time.